Good evening. Today we would like to present a case study of soil remediation from soil contamination regarding standards and European core values. This project was prepared by Veronika, Zofia and Arina. Now we would like to present you the threats of soil contamination with fuel.
Fuel spills cause soil contamination with organic compounds, mainly hydrocarbons, which are difficult to clean up and are hazardous to living organisms, including humans. One of the main sources of soil contamination by diesel fuel is road and rail transport. Contamination occurs primarily during accidents and collisions, resulting in emergency fuel leaks from damaged vehicle tanks. Leaky fuel systems in lorries, buses, construction machinery, and stationary machinery also pose a risk. Even small but prolonged leaks can lead to the gradual accumulation of pollutants in the soil. In the industrial sector, soil contamination stems mainly from leaks in infrastructure used for the storage, transmission, and transshipment of fuels. The risk is present at fuel terminals, railway sidings, transport depots, and petrol stations. Contamination can be caused by damage to tanks, pipelines, or transshipment systems, or by accidents during refueling and fuel transfer. Prolonged leaks often go unnoticed, leading to diesel seeping into the soil and groundwater. Farms and private properties are also a significant source of pollution, as fuel is often stored there in old, corroded, or inadequately secured tanks. Leaks from tractors, combine harvesters, and other agricultural machinery that are not regularly serviced also contribute to pollution. A further problem is the illegal dumping of used fuels and other petroleum products directly onto the ground or into ditches, which causes localized but often very severe environmental pollution. Aromatic hydrocarbons are difficult to remediate because they are highly chemically stable, can penetrate deep into the ground, and can clog soil pores, thereby inhibiting the flow of air and water. This is because most hydrocarbons have a lower density than water, which allows them to float on the groundwater's surface. Aromatic hydrocarbons are among the most toxic components of petroleum products. Some of them, such as benzene, have been classified by International Agency for Research on Cancer as Group 1 carcinogens for humans. Long-term exposure can lead to the development of cancer, including leukemia, and can also cause damage to genetic material, the liver, the kidneys, and the nervous system. Aromatic hydrocarbons are also hazardous to animals and plants. When they seep into the soil, they can be ingested by organisms or absorbed through direct contact, causing metabolic disorders, stunt growth, or organ damage. Water birds are particularly vulnerable. Contact with petroleum product leads to a loss of the insulting properties of their feathers, hypothermia, and often death. On the surface of plant leaves, hydrocarbons can form a thin film that restricts light penetration and gas exchange, thereby reducing the intensity of photosynthesis. As a result, growth is stunted, leaves turn yellow, which means chlorosis, and plants die.
We will introduce our case on an example of an illustrative company. Kopol provides comprehensive environmental and land management services for property owners and landholders. The company supports clients throughout the entire remediation process, from site contamination assessment, including the identification of historical activities that may have contributed to land contamination, through the development and implementation of remediation strategies, to long-term environmental monitoring. And now we would like to present to you a real-life case of our company's work. And on this example, we will show how certain standards and European values can benefit environmental protection. A potential land buyer came to us and asked Kopol Company for an environmental assessment. By research on old maps, our company found that in the past a gas station was located on this plot. This finding was grounds for conducting a soil pollution analysis. It was found that soil on the plot was polluted with fuel leaking out of the faulty fuel tank. Soil was polluted on an area of 1.6 hectares, and the total volume of fuel in soil was 1.8 million liters. Main aim of the initiative was to reduce the amount of fuel in soil and mitigate the negative effects of pollution on the environment.
For the recent situation, soil remediation using the pump and treat method is planned. This is a soil remediation technology which involves pumping out contaminated groundwater, treating it in an above-ground facility, which means ex situ, and then re-injecting it back into the aquifer. This is mainly used to prevent the migration of contaminants. The pump and treat method utilizes various components such as activated carbon filters, separators, ozone, and biological additives to achieve the required water quality before the water is returned to the groundwater environment. Activated carbon filters help to remove organic substances, separators are used to separate solids, and ozone is used to disinfect the water. The addition of biological agents can support the natural biological processes involved in removing pollutants. This method will be better explained in the next video.
Pump and treat is a common method for cleaning up groundwater contaminated with dissolved chemicals, including industrial solvents, metals, and fuel oil. Groundwater is pumped from the wells to an above groundwater treatment system that removes the contaminants. Pump and treat methods may involve installing one or more wells to extract the contaminated groundwater. Groundwater is pumped from these extraction wells to the ground surface, either directly into the treatment system or into a holding tank until treatment can begin. The treatment system may consist of single cleanup method, such as activated carbon or air stripping to clean the water. However, treatment often requires several cleanup methods if the groundwater contains different types of contaminants or high concentrations of a single contaminant. The approach to the treatment may be modified as contaminant concentrations decrease.
For more information about in situ remediation, visit irsl.ca.
In our remediation project, we use two types of bioremediation: biostimulation and bioaugmentation, last one in cases where the soil to be remediated lacks its own bacterial strains. Bioremediation is a technology for removing residual contaminants, mainly petroleum-derived substances, from soil and groundwater using living microorganisms to catalyze, destroy, or transform various types of contaminants into less harmful forms. Biostimulation and aeration are in situ, which means at the site of contamination. Remediation techniques used to accelerate the activity of microorganisms by creating favorable conditions. Bioaugmentation involves introducing selected bacterial strains into contaminated soil that are capable of breaking down specific substances.
In all this work, we use specific standards which provide us with consistency, safety, and efficient communication. They ensure that planning and operations are optimized and effective, while reducing errors and saving both time and costs. Consistency will facilitate business management and development both in Poland and across Europe. Without standards, everyone would measure pollution differently. The results would not be comparable. In the process of identifying contamination and remediating a site, we rely on several key legal regulations and technical standards. First, the Environmental Protection Law defines the concept of remediation and imposes an obligation to clean up soil and land when concentrations of hazardous substances exceed the permissible limits. Second, the regulation of the Minister of the Environment on the method of conducting an assessment of soil and land surface contamination establishes threshold values for chemical contaminants in soil, including petroleum hydrocarbons, fuels, oils, and aromatic compounds commonly associated with former fuel stations. These limits vary depending on soil type and sampling depth. Another important legal act is the Act on the Prevention and Remediation of Environmental Damage, which regulates liability for damage to soil and groundwater environments and sets out the principles for environmental restoration. From a technical perspective, we follow the PN ISO 10381 soil quality sampling standards. a series of standards that provide guidance on designing sampling programs, selecting appropriate sampling techniques, ensuring safety during fieldwork, and handling samples contaminated with petroleum products. To assess the potential migration of contaminants from underground fuel tanks into groundwater, we apply PN-EN ISO 15175 Soil Quality, Characterization of Soil in Relation to Groundwater Protection. All chemical analysis of soil and groundwater samples must be carried out by laboratories accredited according to PN-EN ISO IEC 17025, the internationally recognized standard for testing and calibration laboratories. In Poland, such accreditation is granted by the Polish Center for Accreditation, PCA. When biostimulation techniques are used, the effectiveness of indigenous microbial communities is evaluated using PN-EN ISO 16072, which describes laboratory methods for measuring soil microbial respiration and biological activity. Finally, to verify the ecological safety of the soil before and after bioaugmentation, we use PN-EN ISO 22030, the biological testing standards that assesses chronic toxicity effects on higher plants. Together, these regulations and standards provide the legal, technical, and scientific framework necessary for the assessment, monitoring, and remediation of contaminated land. Standards, both informal best practices and formal regulations, issued by Polish and international institutions, are essential to our work. By adhering to legal requirements as well as Polish and international standards throughout the investigation process, our company consistently delivers high-quality results and has earned a strong reputation across the European market. The use of standardized methods and tools for the removal and remediation of contaminants gives our clients confidence in our services while ensuring that our work is recognized and accepted by the Regional Directorates for Environmental Protection, RODOŚ.
To obtain valuable information about the current state of soil condition and in compliance with required standards, the company utilized ground-penetrating radar. It's a mobile geophysical device that uses electromagnetic waves for non-invasive testing of soil structures or other materials. It was used to survey the ground prior to the installation of testing and monitoring equipment. Drones are unmanned area vehicles that are either remotely piloted or fly autonomously. They were used to conduct an aerial survey of the vegetation condition within the studied area. Databases are a collection of information or data compiled and are stored within the computer system. They were utilized to gather all necessary information, both current and historical, regarding the site conditions. You can get to know more about information about the ground penetrating radar in the next video.
Ground Penetrating Radar, or GPR, is a powerful tool used across fields like archaeology, engineering, and environmental assessments. But how does it work, and what factors influence its effectiveness? GPR works by emitting electromagnetic waves into the ground and analyzing reflected signals. The frequency of the waves, ranging from 10 MHz to 2.5 GHz, determines how deep they can go and the level of detail that can be captured. Low frequencies offer deep ingress, ideal for geological surveys but with lower resolution. High frequencies, while providing detailed images of small features like pipes, are limited to shallow depths. Soil type greatly affects GPR performance. Soils with high dielectric properties like clay weaken the signal, limiting perforation. In contrast, sand allows more depth but may result in weaker reflections. Moisture content plays a key role too. Wet soil increases ingress by raising the dielectric constant, but too much moisture can weaken the signal, complicating data interpretation. By understanding the interplay of frequency, soil type, and moisture content, you can optimize your GPR surveys for more accurate and effective subsurface investigations. unlocking its full potential for a variety of applications. Call us today to understand how GPR can be utilized in your current project needs.
The application of work automation methods and digital tools align with the EU digital strategy. The data used in the process was obtained from publicly available sources. The results, such as information of soil contamination and specific pollutants, were shared with the relevant authorities and uploaded to databases. This approach is a key driver to digital transformation in Europe, enabling the development of digital technologies, data processing, and modern IT infrastructure.
The European Green Deal is an European Union strategy whose main objective is for the European Union to achieve climate neutrality by 2050. It aims to reduce greenhouse gas emissions by at least 55% by 2030 compared to 1990 levels through the modernization of the economy, the energy sector, transport, and agriculture. Soil remediation and restoration contribute significantly to climate neutrality by reducing greenhouse gas emissions, as the land will be grassed over once remediated, which will substantially increase the uptake of greenhouse gases from the atmosphere. Furthermore, the vegetation introduced will significantly limit the potential volatilization of hydrocarbons from soil and prevent wind and water erosion, thereby contributing to air quality.
Eventually, common standards ensure consumer safety, environmental protection, and fair competition within the single market. They enable seamless cross-border cooperation, facilitating trade and everyday life. Effective soil remediation required a combination of environmental protection, quality standards, and modern digital technologies. This helps achieve the goals of the European Green Deal and the EU digital strategy.
We would like to highlight that this project was made in accordance with standards specified in assignment instructions.
And we kindly thank you for your attention.